So, do we start the slide deck? Hello, everyone. I'd like to welcome you to our presentation today. Let me first of all introduce ourselves. My name is Sebastian Bauch. I'm a Java developer at Aperto and responsible for the backend development of the project. The co-presenter today is Mörner, as the lead systems engineer at Aperto, and he's responsible for the project's overall architecture. In the following 15 minutes, we will present how we use Magnolia Headless with NextJS and Kubernetes for our clients, the Berliner Verkehrsbetriebe. I start by giving a short introduction to the client, talking about the requirements, the tech stack, and how we use Magnolia and how we set up the development with Magnolia and NextJS. Then Martin will show how we set up the Kubernetes environment and give some insights into the technical details. And finally, he will wrap up the presentation with providing some insights into the problems we had during the development. So the setup, let's go. What is the BVG? The Berliner Verkehrsbetriebe is Germany's biggest public transport company. They keep moving for over 90 years and covering an area of around 892 square kilometers. With more than 15,300 employees, they manage the city's underground railway, bus, tram, replacement service, and at least also the ferry networks. With combining of available ways of moving around, the BVG wants to provide a new approach of travel activities, and at least they want to be the leader in providing mobility services in the city. So what is the page we're talking about? After 6 months of development, we had a beta go live of the new digital station. This was a MVP version of the page, which contains the base or the key functionalities of the site. So we have an entry point for planning routes, getting informed about disruptions, and more traveling related informations. After the go live in the next month, the page will also provide a self-service for functionality to manage subscriptions and other concerns quick and easily online. So let's talk about the requirements of the page. First of all, the whole architecture has to be future-proven. The page will be the central point for many BVG services. And so the architecture has to be suitable and sustainable for the next 8 years. Further, it has to be scalable and it has to be easy to integrate new services or third-party systems, for example, via an API layer. But also the front end has to be state-of-the-art. For reusability and testable reasons, the front-end components are decoupled from the backend. So it's easy to add new features or replace them within when they're not longer up to date. And at least it's about performance and stabilizations. In any case, the page has to perform within maximum 3 seconds, the response time, and be stable with an uptime of 99.9% per year. So, how does our tech stack look like? On the front end, we use the React framework for creating reusable and well-tested components. Then we have a story box. It's mainly our catalog view on our front-end components. so that we can share them with other service providers or with other agencies. They have a quite nice look at the components, can see the documentation and every kind of variation of each component. Further, we have NextJS for the server-side rendering and also Learner to handle our mono repo. On the backend side, we have Magnolia as a main CMS, and in this case also as a content app. Further, we use Spring to create additional services or microservices which we want to share with other agencies, and which has features we don't want to integrate directly in Magnolia. Further, we have Kubernetes, mainly for managing our Dockerized applications, for scaling, and so on. Then the Nginx, mainly for routing, caching, and the HR proxy as an entry point to our architect, and more or less also as a load balancer. Let's talk about maybe the interesting part, how we set up the development environment, in this case for our front-end setup. The development team counts 3 developers. So it's me in the backend and 2 front-end developer. Our aim was that the front-end guys do not have any do not have to handle in any case with the Magnolia code or so on. So they start the Magnolia in a Docker container. In Magnolia, we use the extended SPA rendering modules provided by Magnolia, but we also add some special feature to it. In this case, to support components inheritance, auto-generation content, and any case of redirection for the front end. Outside of the container, we have our light modules. In this case, for example, for all the template definitions, pages, components, dialogues, and so on. So it's easy for the front-end guys just to create components and add EACs and N labels and so on without any help of mine. Further, we also share development content via light module. So as I said, they will never have to handle in any case the Java code. On the front-end side, we rely on NextJS and Storybooks. We use also the React component from Magnolia, but we also have to extend it a little bit. In our case, that we can support barrier-free markup, and also have support of dialog properties in the author view. The frontend has a direct connection to any other services. In this case, also the keycloak for SSO handling, the connection servers, the tracking news, and other services which we or the BVG or other agency provides via the API layer. So I can see Martin. So I will hand over to Martin, and he will show you how we use Kubernetes. Let's go.
Thank you, Sebastian. Let's go to the next slide. As you can see, and Sebastian talked about that, we have a lot of stuff to do, so don't be too overwhelmed. I won't go to every detail on this slide. It's just to give you an overview. We're using everything in Kubernetes, so the whole thing runs in Kubernetes as well as some other stuff. The main point I want to show you with this slide is that how the setup works. So we have the HA proxy in the front, the customer client-side facing stuff. Normally in other clouds, we would use just an ingress controller, but here we have a special cloud provider which uses HA proxy. So we have to use that. And we use Nginx for the specific simple routing stuff and almost for everything in caches. As you can see, the arrow below shows that we get some static stuff and some Magnolia API stuff directly to an internal balancing service to the Magnolia public instances. Everything else goes to the front-end stack. The front-end stack is an horizontal autoscaled stack, which we use because we have to render all the stuff, which is quite performance enduring. And so we have to autoscale here if there's more requests coming. For example, a typical thing is if there is a strike happening, then the traffic peaks a huge lot because a lot of people have to travel and have to take the BVG. And so a lot of people go to the website to have to look up when the strike ends, when they can take the subway and everything else. So therefore we use an autoscaling there. We have the two Magnolia public instances there running. They both just have an Nginx for other accesses like monitoring and secure stuff and HTTPS. And then on the backend, we have the authoring instance, which combines all three together, having the Nginx, the Magnolia author instance, and then a Node.js instance for the front end rendering locally inside the author pod. So everything is contained in that system. And besides that, we have some database stuff in the backend for clustered workspaces, some single sign-on stuff, which runs in another namespace in the same Kubernetes cluster, and some other little stuff like a disruption API stuff, which we use for disruption reportings and connections to other API layers and stuff like that. So as I see Christopher, I guess I only have 5 minutes left.
Coming up. We've got 7 minutes total.
All right. So let's go with some technical details. For the public instances, we use H2 database instead of classical relational database like Postgres or MySQL. We choose this because we want to have the ability to clone instances, to take snapshots and produce new instances, or to directly clone for other environments. And it's a little bit easier for making backups because you make the backup of the whole instance as one and not at separate times in the database and your deployed instance code. For the routing, we have some extra stuff, as I mentioned before, in Nginx, which just routes to different targets inside the Kubernetes cluster, different services. And some routing is done in the front end, where, for example, the SSO logins and stuff like that is happening inside the front end and inside NextJS. The cache is heavily used in Nginx because we have a lot of performance requirements that we have to meet and a lot of availability requirements. So we use the classical Nginx file system cache. The lifetime of these cache objects is maintained by Magnolia. So an editor can say how long an object could live in the cache just by normal caching headers. And Magnolia itself uses its own rendering cache for the API endpoints. And then we have some independent services that also produce some caching stuff and used for the disruption reports and the subway line PDF, which I never used before, but apparently a lot of people like to have PDFs on their mobile phones about their train as subway lines. Let's go to the next slide. Let's see. The deployment stuff we use is just the normal deployments in Kubernetes. So we deploy the front end, for example, as a normal deployment. The update strategy is just the normal rolling update strategy. We looked into having blue and green deployments or green-blue deployments, but we decided to use the rolling update to get the stuff a little bit faster. For the public instances, we choose to use stateful sets because of dependence licensing issues and to have a full validated and always the same name inside the cluster for the public instances, and also that the target always remains the same for publishing stuff. So the author instance always can make sure to publish to public 0, public 1, and however many publics you have. We use some status checks for the Magnolia instances and some health probes like the REST status component and other monitoring endpoints to monitor and give Kubernetes some insights into Magnolia. We do the same in the front-end part where we use some NextJS endpoints to tell Magnolia, Kubernetes here, look at that point, monitor that stuff, and please do something if it doesn't work. And for other deployments, we use multiple tags for the different environments for the same image and different sprints so we can work within the two-week cycle. But that's just all the boring stuff. Let's talk about the most important stuff. What have we learned and what were some hurdles and what didn't work or what did work?
And Martin, I would say, We have 4 minutes, including questions left. There is one interesting question, so
yes,
it's up to you if you want to present or if you want to.
Yeah, just check the question, please.
Okay, so let's see what happens when I say publish. I think it might. Do we see it? Anyways, I'll read it out loud. This is from Alberto Soto Fernandez, and he's asking, how has been the transition with SSR Next.js in terms of cache and speed of the platform for you? Did you make any comparison with the rendering times compared to a Magnolia FTL cache?
We didn't make some comparisons, but we made some performance tests and heavy load testing, and we found that the Nginx cache is very performant. What I would like to do is to see if the caching inside the frontend and the Next.js frontend, if that server-side cache would work at the same way and the same performance, but we haven't done that. The point is we choose to have the cache inside the Nginx, so as far ahead to the client as we can do, and to use the cache for other components as well. But my guess is, because we choose to move some image caching stuff into the Next.js frontend, that we will do some caching there as well. But I can't tell you any performance measurements on that.
Mm-hmm.
Okay, we'll continue with the learnings. One hurdle we had was to get the authoring instance to have the preview of the green edit bars, which uses the React editor, which sometimes creates invalid HTML inside through the injections in the HTML tags, where you have some comment and then the Magnolia React editor inserts that, which isn't so well. But we use the editable components on the editable areas to remove the enclosing diffs to have a valid layout. We would like to use overlays there, or maybe Magnolia has some stuff in the future to use overlays there, because it works quite better to have that instead of having HTML injected into the preview and to make the buttons clickable.
Mm-hmm.
That was one problem we faced. Another problem or another change we want to do is to make, as I said, deliver images via Next.js and to have some scaling of images, different formats of images in the front end. The next lesson learned is we had the beta phase, I think, for 3 months or 2 months now, and had some outages. That happens because we learn. And the basic learning was use Kubernetes routines as much as you can. Don't invent your own stuff. Don't reinvent the wheel. Kubernetes offers you a lot of routines which do checkups, health probes, and all that juicy stuff that makes your life easier, annotations and stuff like that. It helped us a lot. Another hurdle we had doing development was the local development with for the front-end guys, because when we use Kubernetes, we have Next.js and Nginx and internal services inside the Kubernetes, and you don't have that locally. So 2 things you can do, which our developers did, was to run a local Node.js proxy that does the same thing as our Next.js, as our Nginx and services in Kubernetes does. Or another thing is to run Minikube on your local dev machine and then have the same services running there as in the cluster.
All right.
And the last thing I want to tell, just one more second, is the clustered workspace is a nice feature, but it's also a single point of failure. So we have to look into that, how to mitigate that single point of failure, because otherwise you don't have much to win if you use 2 instances that can fail on one thing. So that were the learnings we had, and it was a really nice project, and I'm excited to see how it behaves when it goes really online.
That's great. That's fascinating. We're very interested in all of the frameworks that are kind of in the SPA community. So we'd love to exchange more with you on that topic. So thank you very much for sharing today, guys. It was really, really interesting.
You're welcome.